Hello again, fourth grade math. Today's lesson is 13.6, and we're going to talk about mixed numbers. And in your textbook, we're going to be on pages 560 through 563 to complete your assignment for today, okay? So right now, I'm going to start on page 560, and we're going to start with the Get Ready to Learn. And it says, Nayoko is selling pies at a bake sale. Each pie has 5 slices. Each slice of pie is sold separately. There are 7 slices left. What fraction of the pies is left? So today we have 2 new math concepts that we're going to talk about, okay? And the first one is a mixed number, okay? And a mixed number has a whole number part and a fraction part, okay? So a whole number part means, like, for example, it could be 1 whole and we still have more left. So we have 1 whole and 1/4 or something like that as an example. So it has a whole part and a fraction part. Okay, so this would be the whole part and this is the fraction part. Okay, so that is a mixed number. And an improper fraction. So an improper fraction has a numerator that is greater than or equal to its denominator. So remember, the numerator goes on the top, right? So we have a fraction. Our numerator might be 12 and our denominator is 6. So this is an improper fraction because our numerator is greater than or equal to our denominator, okay? So the numerator is greater than or equal to its denominator. Okay, so the numerator, remember, is always on the top. The denominator is always on the bottom. So this is an improper fraction because the numerator 12 is greater than the denominator 6. Okay, so let's do an example together. What fraction of a pie does Naiko have left? Each pie has 5 slices and there are 7 slices left. So we can think about it as a mixed number, or we can think about it as an improper fraction. So let's look at a mixed number. So we know that each pie has 5 slices. So we have 1 pie has, how do I draw 5? That's kind of complicated. 1, 2, 3. Oh gosh, that's kind of terrible, isn't it? Okay, let's try again. 1 whole pie has 5 slices. 1, 2, 3, 4, 5. There we go. 5 slices. Okay, and let's try another one. Okay, so these, I've got 1 whole pie is got 5 slices, and we have 7 slices left over. So that means we have 1 whole pie because we have 5 slices right here. 5, 6, 7. Okay, so on this, I have, how many parts are shaded? Well, I have 2 of 5 shaded, right? 2/5 shaded. So that means I have 1, 2, 3, 4, 5, 6, 7 slices. That means I have 1 whole and 2 more fifths of a pie. Okay, so that's a mixed number because I have 1 whole part and a fraction part. Okay, so this is a mixed number. All right, so then you can also think about it as an improper fraction. So we can just think about it as separate parts, right? So I'm going to draw 7 slices. 2, 3, 4, 5, 6, 7. And each of these slices is 1/5. Sorry if this is kind of hard to see. So I have 1, 2, 3, 4, 5, 6, 7 slices of 5, because remember 5 makes our whole. So as improper fraction, this would be 7/5. And why do I know this is an improper fraction? Well, the numerator, the top number, is greater than the denominator, the bottom number. So this is an improper fraction. Okay. All right. So now we're going to talk about how we can change fractions kind of back and forth between mixed numbers and improper fractions. Okay. So I'm going to get a new piece of paper. And I'm going to look at the next example. And this is on page 561. If you want to look back or follow along with me, okay? So it says write 1 3/8 as an improper fraction. Okay, so right now it's a mixed number because there's a whole part and a fraction part. But now it wants us to switch it into a improper fraction. Okay, so what we're going to do is we're going to say that this mixed number is equal to 1 whole plus 3/8, right? The whole part and the fraction part. Okay, so what is 1 whole in this fraction? Well, 1 whole would be 8 parts of 8, right? Because that would mean that a full maybe circle or something, all 8 parts would be shaded in. That's 1 whole. But we also have 3 more 8s, okay? So then we can add these together. So we're going to add straight across the top. So 8 plus 3 is 11. And our denominator is going to stay the same because that's how many equal parts we're still using as a fraction. Okay, so 1 3/8 is the same as 11/8. Okay, so now we're going to go backwards. And what if we started with our improper fraction, 11/8? How can I change this into a mixed number? Okay, well, I don't know if you remember, but fractions are also division problems. So that means that 11/8 really is 11 divided by 8. Okay, so I'm going to solve this equation. I'm going to say, okay, how many times can 8 go into 11 without going over? Well, only 1 time. And 1 times 8 is 8. And I'm going to subtract. 11 minus 8 is 3. So that means I have a remainder of 3. Well, guess what? My denominator is still going to be 8 because that's how many equal parts we're still working with, right? So that means I have 1 whole and I have 3 parts of 8 left over. Okay, so my 1 whole part came from my answer right here. Okay, my remainder became my numerator and my divisor became my denominator. Okay, all right, if you have any more questions or want to do more practice, you can keep looking on page 561 for one more example using a number line. But if you still need help or have questions about how to go back and forth between a mixed number and an improper fraction, please let me know. All right, see you again soon.